Okay, so in this video, I'm going to briefly discuss rhombi. Rhombi is actually plural. Okay, it's plural for the singular rhombus. Okay, anyway, a rhombus or rhombi are quadrilaterals uh, with four congruent sides. Okay, and because they have congruent sides, that also means that they have to have opposite angles congruent as well. So here we see a classic example of what we think of when we think of a rhombus. Okay. So we see 1, 2, 3, 4 sides all measuring x in length, right? And if I go ahead and label the vertices, so A, B, C, and D, we see that AB, BC, DC, and AD are all equal to x in length. They're all congruent in length. Okay, so that said, because all four sides are congruent, we also have opposite interior angles congruent as well. Okay, which means that they are ultimately also parallelograms. All rhombi have to be parallelograms. Okay, and we see that that's also going to be true that opposite sides are going to be parallel. Okay, so AB is parallel to DC and BC is parallel to AD. Okay, so now let's get into the particulars of the diagonals. So we're being told here in this text that they are perpendicular and bisect each other, and they bisect their respective vertices, originating and terminating. Okay, so what does that mean? Well, let's draw this out. So if I go ahead and draw the diagonals, so I connect vertex A to C, see if it'll let me duplicate it, maybe. And I connect vertex, oh cool, it just didn't let me do it. I connect vertex B to vertex D now. Okay, two things are true. First of all, we see that they intersect at 90 degrees. Okay, so vertex AC, or not vertex, diagonal AC is perpendicular to diagonal BD. Okay, the other thing that we see happens is bisection occurs. This point of intersection here happens at the midpoint of both DB and the midpoint of AC. So this means that they cut each other in half. Okay, and not only do they do that, okay, but they also bisect their respective vertices. So let's talk about vertex A and vertex C and the corresponding uh, diagonal therein, right? So diagonal AC cuts alpha 1 and this other alpha 1 into two equal pieces. So, for example, if alpha 1 was 60 degrees, each of these pieces right here, so this piece right here in pink, that would be half of that, 30 degrees. Just like this piece and this piece over here would be half of that. Okay? If this angle, alpha 2, if alpha 2, for example, was equal to 120 degrees, right? It's safe to assume that each of these pieces would be 60 degrees. Okay, so we have bisection of vertices and bisections of one another. Okay, and then something interesting over here. So what we've got here is a square. A square is also a rhombus. Why is a square also a rhombus? Four congruent sides. It's also going to have opposite angles congruent, so 90 opposite of 90, 90 opposite of 90. Okay, and it's even better. The diagonals are going to bisect each other at their point of intersection. They cut each other in half. They intersect at 90 degrees. They're perpendicular, right? And this angle is being cut into two pieces from 90 into 45. Okay, so rhombi are pretty interesting. Okay, so that does it for this video on rhombi or rhombuses. If you have any questions over rhombi, obviously shoot me an email or come see me. Goodbye.